So now that we've seen how to build residual plots, I reiterate that we do not want to see a pattern to them. And unfortunately for us, in this particular case, we see a pattern. So what's happening is this first dot, see that? How that's a little bit below? That's the distance below. And of course, the scales are different here. This is by going up by 0.1, 0.2, and so on. Then this one is a little bit below. That's right there. Then this one is a bit above, a bit more above, below, right? Above. See how that one's the most above? That's this point right there. That one. Right there. Okay. And you can see that there's kind of an up and a down. That's not good. We want to see the points scattered all over like this. We want to see them like that. But if you see them form kind of a parabola shape, that means that this wasn't really linear to begin with. And I know it has a really high r squared. I mean, r squared of 0.99, that's ridiculous. It's crazy high. But look at these points. They're not really a line. I know it looks like a line, but it's actually more of a curve. It's kind of an exponential thing. So, even though r squared equals 0.9903, oopsie, I thought I pressed the button on there. This data wasn't really linear. And so a linear regression model is not appropriate. How do we know it's not linear? Appropriate. Oh my goodness, I can't spell. It wasn't really linear because the residuals form a parabola pattern. And so a linear model is not appropriate for this data. I don't care how high your r squared is. If you see a pattern like that to your residuals, something else is going on. All right, so what else? You can look for a pattern. Pattern is bad. The other thing you want to see is you want to see the points be homoscedastic, meaning they're up and down the same amount every time. It's called a constant error variance. That is not the case for this particular example. So you can see the points start off really close and get worse and worse over time. This is the scatter plot, and then this is the residual plot where they took the line and they kind of tilted it, and you can see the distance. See how it's forming kind of a horn shape? You don't want to see that. If you do, then that's not good, right? So this data is not linear and should not have a linear model created for it. Linear model, i.e. Least squares regression line created for it because there is a cone shape, horn shape, whatever you want to call to the residuals. And it can face either direction, by the way. This one happens to be a cone shape facing right. Cone shape facing left is also bad, right? You want them to be, this is called heteroscedastic, meaning it gets, they're not the same. The up and downness of the residuals is not varying across, right? So we want it to be homoscedastic. We want it to be equal amount of variability all the way through, right? Homo meaning the same, hetero meaning they're different. Like here it's small, there it's great. That's bad. We don't want that. We want it to be homoscedastic, meaning equal amounts of distance, more or less, the whole way through. If a linear model is not appropriate, just notice this right here, then everything that would come from a linear regression line is worthless. Worthless. So that means that, like, look at this one. This one had a pattern to it. We did all of this work. We analyzed the coefficients. We analyzed the intercepts. We did, all this jazz, but it's worthless. Right? All of that stuff is worthless because this forms a pattern. So the rest of the stuff the computer will do for you, but you have to know I shouldn't be using it because there was a pattern to those residuals. The pattern to residual means you shouldn't be doing any of this other stuff. Right? It all is meaningless. All right, now the last bit is, we won't have time for here, but let me just start it. You can look for outliers in residual plots, just like you can in scatter diagrams and box plots. We've seen outliers in those two locations as well. You can also see them in residual plots very simply. All right, we'll pick it up right here next time.